Welcome to All Things What. In this episode, we will be talking about space-time curve. Space and time is not related. This was the common belief set by Isaac Newton in his laws of gravitation in the mid-1600s. Until in 1915, Albert Einstein published his theory of general relativity that talked about space-time relation and how it was curved especially around massive objects. However, this theory required some sort of experiment to prove this radical idea. Now, human beings have been studying the night sky for ages. We know with very high accuracy the location of known stars and planets at any given time. Einstein suggested that a perfect scenario to carry out the space-time curve experiment would be to observe the location of stars in an event of a solar eclipse, where the stars appear in the sky in the daytime during totality, and contrast that with the actual location of the stars. So in 1919, an experiment was carried out by Sir Arthur Eddington to observe this phenomena. The experiment is as follows. We have the sun in orange, and then we have the earth in blue, which is revolving around the sun in this elliptical orbit. We also have the moon in gray, which is revolving around the earth in its elliptical orbit. We have three white stars which are fairly close to the sun in the terms of an observer. When he looks up to the sun, the location of the stars are within proximity. So during a solar eclipse, the moon comes directly in between the earth and the sun to form the ring of totality. At this point, the sky becomes dark for a few minutes, and we can observe the stars around the sun, which we couldn't have without the eclipse because it would have been just too bright for us to see. So what did Eddington observe? He saw that the stars were actually shifted outwards. So these white stars here, they were shifted and they appear to be slightly off position from the actual location and towards outside. Now, the experiment proved that the space-time is curved around the sun, and the light from the star actually bends around the curve to get to the earth or to our eyes. So the actual path that the light of the star takes is this, and it bends around to get here, but our eyes actually cannot traverse the curve and we can only see straight. So for us, when we look out, the star actually appears to be shifted away. Now this can only be possible because of this curve, and hence space is curved. But what is it to do with time here? Why is it called space-time curve? This is due to time dilation, which I talk about in my earlier videos. Check it out if you haven't. Essentially, time moves at a different rate in space because of the fabric curve caused by the mass of the objects, and the distance traveled by the light is higher around massive objects than around no objects. But given that the speed of light remains constant in both of these reference frames, this can only mean that time must be varying. And this is why space and time are related. I hope you enjoyed this video. Stay tuned for more on All Things What.